Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to explain the topic nomenclature of the coordination compound, and the chapter is coordination compound for class 12, and that is according to CBSE syllabus. This part 5a, that is nomenclature 1, part 1, and from the nomenclature I am going to start. Then what is here IUPAC? It follows, the nomenclature follows, that is International Union of Pure and Applied Chemistry, IUPAC. That means what is the change regarding nomenclature, that is totally for the whole world. Now formula of mononuclear coordination compound. What is mean mononuclear coordination entities? Entities mean within the square bracket. The coordination compound, the coordination entity mean the square bracket having charge, that is your entity, and it contains single central metal atom. Now the compounds which contain only single metal atom, that is the rules here, that is called mononuclear coordination entities. That means it contains one central metal atom. Ligands are arranged. Then how the ligands? You know the entity within the square bracket, what are present? One is central metal atom, other is, that is ligands. The ligands are two types, one anion or molecule, or maybe both anions and molecules. Now here ligands how can be arranged? There should be alphabetical order. Also it also applied for polydentate ligand. Just like here ligands are Cl minus 1, that is called chlorido. This ligand, name of the ligands also you will learn later. Now here the ligands chlorido, let us Br minus bromido, let us carbonate carbonato. You follow the alphabetical order which will come first. Carbonato, chlorido, and next is bromido. It should follow alphabetical order. Now entire coordination entity, charge or neutral in the square bracket. You know the coordination entity means the coordination complex ion, either cationic complex or anionic complex, and or neutral complex also. What are present? Ligand present, metal present. And here within the square bracket always you observe, I know it is cationic complex, that means the plus charge should be the upper script of right side. In right side you should see after square bracket there is a plus, minus or 0 sign is there. Plus sign complex cationic complex, minus sign anionic complex, if 0 neutral complex. And always in square bracket write to superscript, here you should put plus, minus or 0. Ligands polyatomic, if it is polyatomic, suppose Cl minus, it is not polyatomic. If it is NH3, it consists of nitrogen and hydrogen. Hydrogen how many times? 3 times. Water, H2O, how many hydrogen here? 2 times. Oxygen 1. That means these are called polyatomic. Suppose I want to say 4H2O. How can you write 4H2O? 4 molecules of H2O mean H2O, then after that parenthesis there, and you will write 4. That means here the ligands polyatomic and close in parenthesis, that means here a whole bracket, whole NH3, and how many times? 4, 6, you put 6 below of the, after the whole market, whole bracket you will put that here the 4 or 6. That means here the polyatomic ions are written as the within the parenthesis, and the times, how many times there, that means whole bracket. After that here you will put 4 or 6 on the below. Next here I hope it is clear. Formula of mononuclear mean only central atom 1, and ligand should be written as alphabetic order. Polydentate ligand also we follow the same. And enter, what is mean unidentate and polydentate? Unidentate mean one donor atom, polydentate mean so many donor atom are there to donate electron pair to the central metal atom. Ligands polyatomic and close in parenthesis. Let us see example. In example, I want to show you. Now see square bracket starts. Square bracket starts, square bracket close, and superscript you have seen, that is 0. 0 indicates that is neutral complex, and Cr plus 3 because chloride minus 1 into 3 minus 3, and NH3 that is neutral ligand, and it is see NH3 returns, it is written in what, in parenthesis. How many times? 3. So 3 put here, and this is the central atom, that is plus 3 because plus 3 minus 3 becomes to 0. That means here plus 3 minus 3 becomes to 0. And here also you can see cobalt. Cobalt is plus 3. How you can see? Cyanide, that is minus 1, water is 0, En is a didentate ligand, and water is a polyatomic, but it is only unidentate ligand, and here it is 0 0 and it is minus 1. That is why the chromium should be plus 3, so that the total charge should be plus 2. This is a cationic complex, it is a neutral complex. My request is that when you read, when you see the coordination compound videos, please start from the coordination number 1 to continuously serially see up to 5th A. That means when you start to read coordination compound, please start from the video part 1A. Similarly, you will continue serially one by one, then only it is easy for you, you can understand easily. Next we will see other rules for the formula for mononuclear coordination compounds. No space between central metal atom and ligands. That means here the central, let here example, suppose it is nickel and there is no gap between central metal atom and ligands. How many ligands? 6 ligands. And what is the charge of the ligand? It is a neutral one, so 0. So plus 3 and there comes to plus 3 minus 3 because chloride is minus 1. The charge of the complex are 2 types, mainly positive, negative, and last one is neutral. If it is plus, that is cationic complex. If it is minus, then anionic complex should be balanced. The charge of the complex ions should be balanced by the anions. Let us see here nickel, here plus 3, that is balanced by minus 3. How it is plus 3? I have clear that one, it is 0, so it becomes to plus 3. And here also the ethylene diamine 0, neutral. So plus 3 becomes to here plus 3. That is what is balanced by 3 chloride ion, that is minus 3. Similarly, these two are cationic complex. Then come to anionic complex. See here anionic complex because it is minus 3. How it is minus 3? Oxalato. Oxalato means minus 2. Minus 2 into 3, that is equal to minus 2 into 3, that is equal to minus 6. And here it is minus 6. Minus 6 plus 3, that we equal to minus 3. Again see oxalato ion, the charge is minus 2 and 3 times, so minus 6, and it is plus 3. So minus 6 plus 3 become to minus 3. This is an anionic complex. Anionic complex that balanced by potassium 3. Potassium 1 plus 1, 3 means plus 3. So plus 3, that is cationic charge, that is balanced by anionic charge, where the anion is a complex one. So it is called anionic complex. Then come to rules for naming coordination compound. These are the points where inside the compound, what are the points you should remember. Now it is rules for naming. How can you name it? First point, cation is named first, whether the cation is a complex or cation is a simple one. Just like here, cation is a complex and cation is a simple metal. Then what happened here? This is named first. And in the simple cation, if it is metal and it is simple cation, named first, like this here. Then how to know here which will name first? That means cation is CO plus 3, cobalt plus 3, that is should be named first. And here though it is anionic complex and this is cation, potassium plus 3, that is cation. So potassium, that first you will write potassium. Here first you will write cobalt. And how can you name? I will come to the point. and next what are the rules for the nomenclature of the coordination compound, I am going to proceed. Ligands are named as alphabetic order and before the name of the central metal atom. Now see here, hexaamine cobalt. Cobalt is the central metal atom, and here before the central metal atom, here we put hexaamine. Means amine is 6 times, 6 amine. So NH3, that proper ligand name is amine, hexaamine cobalt 3. Here it comes to 3. That means here the cobalt 3 chloride. Similarly, here tetraamine copper. Tetraamine, 2 types of ligands, amine and chloride. Ammonia is called amine. Chloride is called chlorido. Then how many times? Tetraamine, chlorido, dichlorido, copper. And what is the charge? What is the, I told Roman letter you will put, so copper 2, and this is separate one, sulfate. That means from here to here there is no gap. Tetraamine 2, copper 2, there is no gap. Hexaamine cobalt 3, there is no gap. There is no capital letter. Sulfate is outside part, so you write sulfate within a gap. Now it is a anionic complex, potassium. Since it is cation, you will write potassium. Hexacyano, CN, cyanide group is known as cyano. So potassium hexacyano. Ferret, I will tell that why it is called ferret. Now potassium, first you will write potassium cation, then come to anion, hexacyano ferret, and the charge is +3. Here it is +3 and it is -6. So it is -3. So that means I want to say the ligands are in alphabetical order and it should be before central metal atom. Naming ligands, there are how many type of ligands? One is anionic ligand, and then next is, so many ligands are there. First you should remember anionic ligand, neutral molecule, positive ligand, so many ligands are there. It is called anionic ligands which ends in O, nitrido, chlorido, like this. So Cl minus is called chlorido, Br minus is called bromido, Cn minus is called cyano, NC minus is called isocyano, and O minus 2 is called oxo. So it is anionic ligand. Remember, for anionic ligand you will write like this, O2, that is peroxide, peroxo, OH minus hydroxide, hydroxo, S minus 2 sulfide, sulfido, NH2 minus, that is amide, amido, and NH minus 2 imido, imide, that is imido, N minus 3 nitrido, nitride, nitrido, phosphide, P minus 3 phosphide, phosphido, CO3 minus 2, that is carbonate, so carbonato. That means here only limit number of anions, anionic ligands I have explained. In coming video I will explain total naming of ligands, how the ligands are named according to their charge. So again see, ligands and alphabet written should be an alphabetic order, and that should be in the name before central metal ion and central metal atom. Naming ligands, these are the few ligands which I told the naming, that should be ends in O. I hope it is clear to you, and next coming part 5th B I will explain how the naming of ligands takes place, and after that I will show you how the naming of coordination compounds can be done. I hope it is clear to you. Hope you will subscribe my channel with a small like and share to anyone who require. And thanks for watching my video. Thanks again to all.